Okay, good evening. Welcome to our trim and stability calculation. And this is a three-part series video. On part 1 of our video is we're going to show you how to compute drop and trim calculation, as well as the Hatchwise distribution. And the second part is our initial and final trim calculation, and the last part is the loading sequence. Okay, and I'm gonna show you here. This is the drop and trim calculation form that we're going to use. Okay, here you can see here the form, and we just made it to Excel program. We made this in an Excel so that it will easy for instruction purposes for the video, which eliminates the use of our calculator, pencil, and eraser. Okay, and now we go to our problem. This is our problem now. We're gonna check some here. This is our problem. Voyage number 31, Darlimpol Bay to Shanghai. Our cargo is coal with a stowage factor of 41 cubic feet per long ton. And the dock water density at Darlimpol is 1.022, our loading port. And our discharging port is Shanghai with a dock water density of 1.002, as you can see here. With the deepest drop, Shanghai at 13.5 meter, which is our drop restriction or a drop limit, and our OB departure value of fuel oil is 1180 tons, diesel oil 160 tons, and fresh water 280 tons. We get this value from the engine department, and we are required for maximum cargo to load. And the steaming time from Darlimpol Bay to Shanghai is 15 days, as we computed from our bridgeman in our voyage plan. Took us 15 days to steam, and our consumption per day is 44 tons. Total consumption per day of fuel oil is 36 tons, diesel oil 4 tons, fresh water 4 tons, and a total of 540 tons for fuel oil, 60 tons for diesel oil for 15 days, and fresh water 60 tons, with a total of 660 tons total consumption in 15 days of sailing. Okay, and now we will proceed to our calculation form. Okay, before we begin, this drop and trim calculation form is used to determine the maximum mean drop and the correct data at the completion of loading, in order that the vessel will arrive at the destination not exceeding the drop limit and on even keel. Okay, so since the vessel will depart with adequate trim and will arrive to its destination on even keel, because it will consume the bunker, diesel oil, and fresh water, and arrive within the drop limit, because this is much more complicated than the normal calculation we use according to the load line, because the vessel we will load to its maximum cargo according to its load line limitations, either summer drop or fresh water. or winter North America, and etc. And this time we will compute the maximum cargo of the vessel according to its drop limitation, the maximum cargo the vessel could load according to its drop. Okay, before we begin, we will put some value here for our formula to work. So we're gonna put the total ROVs 1180 tons for fuel oil, 160 tons for diesel oil, and 280 tons for fresh water, for a total of 1,620 tons fuel oil. Total consumption is 540 tons for fuel oil, 60 tons for diesel oil, and 60 tons for fresh water, for a total of 660 tons. And now we will put TPC, okay, TPC of 6.07 and our displacement 07. In this example, we will have a sag deflection 10 cm. Okay, we will now proceed to our calculation form. We're gonna put the date and the loading port here. Okay, I'm gonna check something. So you can notice as we have a colored in this every cell because it is changeable value, so that easy for us. We could easily to determine which is the changeable value. Okay, we're gonna put the drop limit at destination Shanghai with 13.5 meters. Okay, and we're gonna put the water density destination 1.002 and a displacement of 80820 and an LCB of negative 4.26. Okay, now how do we get this displacement and LCB of negative 4.26 and a displacement of 80820 tons? Just go to the hydrostatic table of the vessel. In this problem, we're gonna use extract value from the hydrostatic table of MB Pepetone. Okay, just proceed to hydrostatic table and look for the drop limit at 13.5 meters, and I can show you here with a red line. We have a displacement of 80820 tons. That's why we get the displacement and an LCB of 4.26, negative 4.26. That's why we get negative 4.26. Okay, we get now the seawater displacement at arrival on number 5. By using this formula, we will get the total displacement seawater at arrival. By multiplying the displacement, number 3, 80,820 tons, multiplied by the water density 1.002 divided by seawater density 1.025. That's why we get a total weight of 79,006. And the LCG multiplied by the weight gives us total longitudinal moments. Okay, and now we're gonna put our consumption on each tank. In this voyage, we're gonna use the fuel oil tank number 2, deep tank, and freshwater port and starboard side 1 and 2 tank. Okay, we're gonna put here 540 tons, 60 tons for diesel oil, and 30 tons each for our freshwater tanks, for a total of 660 tons total consumption. And now we're gonna put the LCG of 30.17, 92.74, 103.02, and 104.52. Okay, how do we get this value? Just go to your hydrostatic table of the vessel, and on the forward part of the page, on the vessel's specification, we have the tanks there, cargo hold, fuel oil tanks, and the ballast. You will get the LCG. You just copy it and put right here. Also, you have to copy its sign value, either positive or negative. Just copy here and put it. And now we have a total seawater displacement at departure, which is 79,666.48. On number 7. Okay, we're gonna put the harbor density, which is our loading port. We're gonna put the value here, 1.022, and now give us a total displacement. This is our harbor displacement at loading port, loading berth. It's 79,900.33. Give us a drop at center of flotation of 13.36. Okay, 13.36 is. How do we get this? So proceed again, go to your hydrostatic table, look for 79,900. Okay, just look for excuse me, or the displacement here, which is 79,900. Look for the nearest value. As you can see, you just draw a line here, red line. You can see 79,900, which is the nearest value, and adjacent to it, you can see the drop at center of rotation, 13.36. That's why we get the drop at center of rotation. And you will take note, you will get the value of TPC, which is 65.09, the LCV of negative 4.32, and an LCF 1.25, and our MTC 100.80. Okay, we just put here, we're gonna put the negative 4.32 with the LCF of 1.25 and an MTC 110.80, give us around a trim of almost 0.36, 0.358 centimeter of trim. Okay, right, on the displacement 07. How do we get this TPC? Again, I just show you how to get the TPC on the hydrostatic table. Look for the displacement on your hydrostatic table and look for the TPC on that value, on the nearest value of that displacement. Get the TPC, and now we can put safety margin here, which is the rule of the thumb. Safety margin is multiplied at least 3 times of the TPC. So that's give us around 195 tons. But in this example, we will use 130 tons for our own discretion. But as a rule of the thumb, we're gonna use 3 times of the TPC of that displacement of the TPC multiplied at least 3 times. Okay, and now we have a total cargo to load here, because in our example we have south deflection of 10 centimeters That's why we're gonna use sag in this problem, and our total cargo to load is 68,100 tons. By applying this formula, cargo to load displacement at 7 minus light ship, which is 9502, DROB of 1620, which here displacement number 7, 79,666, minus light ship of 9502, ROB of 1620 minus constant 152, dahag and sag allowance of 163, minus safety margin of 130 tons. So give us a total cargo to load of 68,100. And now how do we get this? The drop of our forward and aft drops is that we have now computed our trim of almost 36 centimeter or 0.358. By applying the formula here, displacement, the total displacement number 7 multiplied by the LCG, okay, the LCG of 3.872 minus the LCB of negative 4.32 divided by the NTC multiplied by 100 give us our trim of 0.358 or 36 centimeter. And now applying our forward drop is you have to subtract the trim, 1/2 of the trim equals your forward drop, and your forward drop plus your trim give us your aft drop. So that's why we compute our drops on the completion of loading. Excuse me. And now we have now computed. Now we are ready to compute our Hatchwise distribution. We can proceed now to our Hatchwise distribution. Okay, so you have to make this in Hatchwise distribution and copy the capacity of each cargo holds from 1 to 7 and the total capacity of all cargo holds. So how do we get the weight? By applying this formula. Weight for each cargo hold, total cargo to load, which is 68,100 multiplied by the hold capacity on cargo hold number 1 divided by total capacity of all cargo holds, 87,298.4, give us the weight of each cargo hold. Okay, and gonna put total cargo of 68,100, and now the Excel will automatically compute us our total weight, exact weight on each cargo hold, and we're going to round off that so that it will easy for our computation. So we will eliminate the 2 decimal point. Okay, so this I'm gonna put 8850 tons, 10,000 tons, 10,350 tons for cargo number 3. Cargo number 4 is 9,500. Cargo number 5 is 10,500. Cargo number 6 is 9,900. And cargo hold number 7, 9,000 tons, for a total of 68,100 tons. Okay, and now we're gonna put this stowage factor of 1.14, which is equivalent to 41 cubic feet per long ton, and this is a sign 1.14 cubic meter per metric tons. Okay, so just gonna copy here, and now we have a total volume. By applying this formula, volume of each cargo hold, okay, round of weight, this is the round of weight multiplied by the stowage factor, give us our volume on each cargo hold. And we're gonna put the kg of at volumetric healing moment or BHM, give us a 10.44, 9.71 meters, Cargo hold number 3 is 9.58 meters. Cargo hold number 4, 9.57 meters. 9.75 for cargo hold number 5. And 9.59 for cargo hold number 6. And 10.09 for cargo hold number 7. So how do we get this kg at BHM? Proceed again to your hydrostatic table. Okay, go to your hydrostatic table. Look for volumetric healing moment table on your hydrostatic table. And in this example, we're gonna use cargo hold number 1. And now, you can see here, total volume of 10,089 in cargo hold number 1. Okay, look to your hydrostatic table, 10,089. I just draw here a line for easy to see to it. 10,089, the nearest value of the volume, 10,089 is 10,140. And look, parallel to it, kg in meters is 10.44. That's why we get 10.44 meters or kg at cargo hold number 1 volumetric healing moment. That's why we get 10.44. It is the same procedure in all cargo holds from cargo hold number 2 to cargo hold number 7. We apply the same procedure. That's why we get the kg exactly in all cargo holds from 1 to 7. See, it is the same procedure as the way we use in cargo hold number 1. And now we just finish our Hatchwise distribution, and we just computed our drop and trim calculation form and our drops on completion of the loading, and our total cargo to load, which is 68,100 tons. And now we are ready to make our initial and final condition for our trim and stability on our next video, and hope to see you there on our part 2 of our video. And thank you for watching.